let's model some quadratics using Desmos. But first, recall that the equation of a quadratic is y equals ax squared plus bx plus c. We're interested in finding the coefficients of the regression equation. And in Desmos, we are going to type it in like this: y1. Instead of the equals, we're going to write a tilde. This is on the top left of your keyboard, and it means approximately equal to ax1 squared plus bx1 plus c. In short, you're going to be replacing the y with y1 and the x's with x1. The a, b, and the c do not have a subscript. If you do not put ones with the y's and x's, you will not get the correct answer. So let's take a look. In this first model, x represents the number of hours after midnight, and y represents the temperature in degrees Celsius. So we want to write a function that models the temperature over time. These points that they give to you are x and y values. So this point right here has an x of 0 and a y of 9.6. This point right here has an x of 4 and a y of 0. And this point right here has an x of 24 and a y of 0. So let's put this into Desmos and come up with the regression function that models the temperature as a function of time. So in Desmos, we're going to hit this plus over here on the top left corner, and we're going to get a table. So in the table, we are going to put in the x values. Now that we have the x's and y's in the table, we're going to type out the regression equation that I showed you on the previous slide. This is what we're going to type into Desmos. So we're going to start out with y1. The tilde is in the top left corner. You can also access it by pressing the ABC, and then down here between the N and the B is the tilde. A x1 squared plus b x1 plus c. So here it gives you the parameters a, b, and c. We can also zoom out by pressing this minus button. It shows you the graph along with the points that we've graphed, or along with just a bunch of points. Okay, so A is 0.01, B is negative 2.8, and C is 9.6. So our regression equation for this model is y equals 0.1 x squared. B is negative 2.8, so minus 2.8x, and C is 9.6. So this is our model. Now we're going to use that model to make some predictions. So this question is asking, how many hours after midnight will the temperature reach its minimum? So how many hours is what they're asking us for. And recall that x is hours, so it's asking us for hours. It also says that it reaches its minimum. That means we're looking for the vertex. We're looking for this point right here. But we're only interested right now in the x-coordinate. So how do you find the x-coordinate of the vertex? Recall this equation. X equals negative b over 2a. That is the x value of the vertex. So x equals negative b. b is negative 2.8. 2a, a is 0.1. So negative 2.8 divided by 2 times 0.1 is 14. 14 hours after midnight, the temperature will reach its minimum. And we can see from the graph that, in fact, this does appear to be about 14. The second part of the question is asking us, what will the temperature be at the minimum? That's asking us for the y-coordinate of the vertex. It appears to be about negative 10, but let's find out. The way we find the y-coordinate is to take the x value and substitute it in for x in our model. So y equals 0.1 times 14 squared minus 2.8 times 14 plus 9.6. So when we do this in our calculator, the answer is negative 10. Negative 10 what? Negative 10 degrees Celsius. And that is actually exactly what we expected it to be, negative 10. Let's look at another one. This one involves a rocket ship. The height is in feet. T is the seconds after starting the flight path. So when you have a table written like this, the first value is typically the x, and the second value is typically the y. So our equation is going to be h equals a t squared plus bt plus c. Let's just use x and y to keep things simple, though. This is x, and this is y. So y equals ax squared plus bx plus c. So what we'll do is we'll go ahead and we'll put these values into Desmos. Okay, so I'm going to press these x's to clear out what I already have. Let's use this plus to make a table. So I'll go ahead and type in the x values. Now Desmos is predicting that these are going to go up by 5. And it's right, I can just press enter until I get to 40. I can only do that because these all go up by the same amount. Now let's type in the y's. Now that I have them all typed in, we're going to use our regression equation. Our equation is y1. We'll use the tilde instead of the equals. ax1 squared plus bx plus c. Now, I'm not getting an answer. What did I do wrong? I put a 1 on this first x, but not on this other x. The x's must have 1s on them. Otherwise, you will not get the correct answer. So here we see our parameters, a, b, and c. So our regression equation is y equals negative 10.95. Let's do 2 decimal places. X squared plus 697.62x plus 21021.4. And this is our regression equation. If you used the TI-84, these numbers might have been slightly different. They might have been rounded a little bit, but that's okay. Our answer will still ultimately turn out to be what we want. So this is the regression equation that we are going to be using. So this question is asking us, what is the approximate height after 28 seconds? Well, the x is 28.8. And the y is what we're looking for. So y equals negative 10.95 times 20.8 squared plus 697.62 times 20.8 plus 21021.4. So when I plug all this in my calculator, the height that I get is 30,794.5 feet. Okay. The second part is asking, when does the plane reach its maximum height? When means we're looking for x. Recall that x is time. Okay. Maximum height indicates that we are looking for the vertex. So we are looking for the x coordinate of the vertex. So x equals negative b over 2a. So this is negative 697.62 over 2 times a. A is negative 10.95. So x is 31.8 seconds. Okay, the last part of this question is, what is the maximum height? Well, to find the maximum height, we're looking for the y coordinate of the vertex. Well, once I know the x coordinate, I can just substitute that in for x to find the y coordinate. So y is negative 10.95 times 31.8 squared plus 697 0.62 times 31.8 plus 21,000 21.4. So when I plug all of this into my calculator, what I get is 32,132.6 feet. Those are all the examples I have. Thank you for watching.